Hello, everybody. Welcome to Lecture 7. So, let's go over a brief review, and then we will get into some flooding and heat waves and winter weather. Which upper air map is best? Well, trick question. We use different maps for different situations. We need to know what feature you're looking for. And yeah, you need to know where the feature is in the vertical to figure out what weather map to use. So, the subtropical jets, ridges and troughs are going to be higher up in the atmosphere, so lower pressures, while the features like fronts, moisture profiles, etc., are going to be in the lower atmosphere, so higher pressures. So let's talk about flooding, heat waves and drought, and winter storms. So, flooding. That's a nice picture. This is what it looks like on, like Jenkins, like by the parking garage on Jenkins, when they have to, like, shut down the road. Because it looks like this. A flood. What is a flood? So, a flood is the overflowing of the normal confines of a stream or other body of water, or the accumulation of water over areas that are not normally submerged. It's the number one weather-related cause of property damage in the United States. Annual damages exceed $1 billion in the U.S. on average. And it's the number two weather-related cause of deaths worldwide. I will say the flash flood warning is a little misleading in my opinion, because a flash flood means that in the county or region that they are warning for, means that one creek, river, etc. overtopped its banks in one place in the entire forecast region. So, kind of like a little misleading, but I don't take risks. If there's a flash flood warning, I usually don't drive in it. What causes most floods? Heavy rainfall. And usually it's heavy rainfall over longer periods of time, so the soil becomes more saturated. And then it can't hold any more water, so it just runs off. What are the three most common causes of floods? Tropical cyclones and very strong mid-latitude cyclones via storm surge. Do mid-latitude cyclones cause storm surge? I don't know, but they do rain a lot. Tropical cyclones definitely cause storm surge, and that just means that the water from the coast is flooding inwards, it's pulled inwards. It's like a bathtub, and it increases the water levels beyond the shoreline. Another cause is snowmelt and ice jams in rivers during the winter. And a third reason is the saturation of soil from previous rainfall with additional rainfall. So, floods are caused by interactions between meteorology and geography. In my opinion, meteorology is geography, but I may be biased because I studied geography for 3 years before switching to meteorology. The geography of the landscape, though, makes some locations more prone to flooding. So, flood duration and intensity? Wow. Oh, I'm from the South, and I have friends in New Orleans. I'm going to talk about Hurricane Katrina flooding in just a second. But let's talk about flood duration and intensity. It depends on many factors. So, the intensity of rain events, the duration of rain events, the number of rain events, the size of the rainfall area, the proximity and orientation to a drainage basin, saturation level of soils, presence of snow and or ice, land use, presence of dams or levees, and the topography along a drainage. So, I guess we'll go into more details in future slides of these. Let's talk about Hurricane Katrina for a second. So, Hurricane Katrina was a serious disaster, and the flooding was incredibly bad. The problem in New Orleans is that the levees were not designed to withstand the amount of storm surge that they had, and they did not redesign these levees until after Hurricane Katrina. So the levees broke, and all of this water that was being held up by these walls poured into the city. I had friends who were sitting on their roofs in these storms because the water levels got so high. It was really one of the worst disasters in United States history. Yeah, the flooding in hurricanes is the main problem. It's the main cause of death. It's not usually the wind. It's the storm surge that really kills people. So, flash floods, we kind of just talked about this. So, it's floods that occur rapidly and with little warning. So, it's a lot of rain in a little amount of time. They're usually localized and short duration, between minutes to hours. And they're primarily caused by slow-moving thunderstorms and high rainfall rates over a short period of time. Yeah, so this is a problem with hurricanes. Usually the worst hurricanes are the ones that aren't moving very fast. So if you have a hurricane that is moving at like 5 miles per hour to the north, it's just going to sit on top of you. And that is where you really get that flooding risk. It can be associated with more injuries and fatalities because these floods are unanticipated. So you can't, if you have a flash flood, you don't usually warn people about them. So people don't have appropriate time to prepare for these flooding events. Since flash floods occur primarily as a result of thunderstorms, this means that they occur primarily in the summer months and in the late afternoons. So in the summer and in the late afternoons, you can just get these pop-up storms that can dump a whole lot of water, and that's when you can really get the flash floods. But I guess not in Oklahoma because it's never going to rain here again. Widespread floods, they occur when a large amount of rain falls over a whole watershed for many days. So you can have moderate rain and lots of time. A watershed is the total area drained by a river and its tributaries. So it's just like the main river channel and all of its forks. Water levels along the river rise slowly and eventually overtop their natural and artificial confines. So widespread floods develop more slowly than flash floods, but they also last longer than flash flood. So widespread floods can last days to weeks. So it's not like one area overtopping its banks. It's very large. It's like the entire watershed has areas where it's overtopping its banks. They often happen as a result of training storms. So a training storm is a storm where they're all passing over the same area for an extended period of time. So they're just like stuck there. And they're usually associated with the stationary front. So yeah, the front is not moving or progressing forward. It's just staying in one place. And then, so the parcels, they form, they saturate, or they form, they rise, they saturate, and then they form clouds. And then they begin the precipitation process. And this precipitation rides the front. But if the front is stationary, it's not riding anywhere. It's sitting in the car in the parking lot. And that means that successive parcels will form and move over the same area. And here's a map of Louisiana. And I guess if it's stationary, that means that this front is not moving. It's staying put. So if you look on a fronts map, you can just Google maps of fronts and you see a stationary front. You say, the risk of flooding is probably higher with this event. Coastal flooding. So coastal flooding occurs as a result of a rise in the ocean surface due to storm surge. So if you have storms and high winds in a coastal area, you can get this. So the causes of storm surge are tropical cyclones and strong mid-latitude wave cyclones. So it basically pulls water into the surface, like kind of like a bathtub. It's literally convergence, but it's within the water. So all of this water converges together and it increases the water level. So the two causes of storm surge are low pressure in the center of the storm and the winds blowing forward ahead of the storm. So the impact of storm surge and coastal flooding, it depends on the region of geographic and topographic features. So it's most extreme along the east and Gulf coasts. Overall flatter topography, because if you have like raised topography, it's going to be harder to get storm surge to get over that rise in elevation. That's why they create levees, because if you have a levee, it just means an area where there's a rise in elevation, and so it kind of artificially creates a barrier for this storm surge and flash flooding. Now, there's also another thing that causes storm surge. This won't be quizzed on, but if you have a concave coastline, so like an area like the Gulf of Mexico along like Alabama, Mississippi, Florida, etc., a concave coastline, it allows all of this water to kind of pile up on itself. So the storm surge is going to be worse. If you have a convex coastline, so like let's say the edges of the Carolinas, it's like jutting more outwards. The storm surge typically in these places, although you can get storm surge no matter what the shape of your coastline is, it's going to be less pronounced than it is in the Gulf of Mexico if you had the same level of storm. This is because the shape of the coastline is going to push water outwards, and it's not going to want to pile up in the same area. So we're going to talk about X-year flood, variable year flood. So hydrologists often use terms like 100-year flood or 500-year flood. And what do these terms mean? So an X-year flood means that in any given year, there is a 1 in X chance of the flood of that magnitude happening. So can a 500-year flood happen more than once every 500 years? Absolutely. This is just an odds thing. Like, oh, the odds of this happening is like 1 in every 500 years. But it could happen 10 times in 1 year, and it would still be I guess maybe they would update their system if that happens. But yeah, so a 1 in 10 year flood, there's a 10% chance it will happen in a given year. And then it decreases up to 500. So a 500-year flood, 1 in 500-year flood, there's a 0.2% chance that a flood of that magnitude happens in that year. So as you increase in the chances, or like as the X value increases, the damage that the flood causes becomes more severe. The impacts of geography. So the ground conditions affects local region's flooding potential. Conditions that can exacerbate flooding include the proximity to rivers, streams, and or lakes, man-made surfaces such as blacktop or concrete, and deforestation. Yeah, so if you have a blacktop or like a concrete area, or mostly that in your region, there's not going to be any soil to absorb this rainwater. All of it is going to run off. So if you have a city that's mostly blacktop or concrete, like, your risk of flooding goes up exponentially. And also deforestation, like, trees like kind of suck up water and prevent some of this flooding. So if you deforest an area, you have less of that occurring. But the conditions that are less supportive of flooding is if you have an area that's primarily sand, soil, and plant roots that are porous and they can absorb water. So yeah, here's an urban area. There's little natural surface. Mostly it's blacktop and concrete, so the water cannot soak into the ground. It just pools up. And the sewers can get overwhelmed and exacerbate flooding. Sound familiar? I guess it does. Norman is very prone to flooding. True. This is true. Norman floods really bad. Here's another example, mountain ranges. So the surfaces are highly sloped and gravity pulls the water towards the ground. So the surfaces are primarily made of rock and they're not porous. So you can have flooding as a large issue in the valleys below if significant rain falls on the mountainside. So yeah, it can fall on the mountainside, especially when it melts. All of that water has to go somewhere, and so it will go into the valleys below the mountains. Driving through flash floods, don't. Driving through widespread floods, don't. Driving through coastal floods, don't. So, turn around. Don't drown. This is a campaign launched by NOAA and the National Weather Service to encourage flood safety. Yeah, don't drive in a flood. It's like, I don't know. It's survival of the fittest. Literally, if it's flooding outside, don't drive your vehicle. So, get out of higher ground and out of areas that are prone to flooding. Avoid the areas that are already flooded, especially if the water's flowing fast, and don't try to cross a flowing stream. And roadbeds may be washed out under floodwaters, so never drive through flooded roadways. You do not know the condition of the road under the water. Yeah, floods are really dangerous, and they're way more dangerous if you're in a vehicle. Your tires don't work right. Your car doesn't work right if it's flooding, and it's just not safe to be in a vehicle when it's flooding. So how deep is too deep to drive through? At 4 inches, the weight of the car is mostly offset by the water. So, yeah, it's already unsafe at 4 inches. At 6 inches, your car begins to float. And your car, if you drive a smaller car, it can literally be swept away. If you have 2 feet of water that's flowing, it can sweep away large vehicles. So it does not take much to get your car off the ground with water in the roadway. But any amount of standing or rushing water beyond a puddle in your driveway is too deep to drive through. Driving through wet roadways is extremely unsafe, and it causes a lot of vehicular accidents, so not recommended. Here's some flood safety videos if you are interested in flooding. Here are some resources for you to look at. All right. Next PowerPoint. So we just talked about floods. We talked about flash floods, widespread floods, and coastal floods. And we talked about the dangers of driving through floods and not to do that. So let's talk about heat waves and drought. So heat waves are the #1 cause of weather-related deaths in the world. Here are some of the health risks. Rash, edema, cramps, dehydration, low blood pressure, heat stroke, and death. Psychological strain. Your productivity goes down, and psychological strain and crime go up. That's not good. I'm sure that there's a link. I don't know if it's correlation or causation, but the PowerPoint says crime goes up, and I kind of want to believe that. Infrastructure. So there's damage caused by expansion and contraction of the ground in high heat. So you can get the cement to crack, the roads to buckle, water lines to burst, and metal kinks. And also to cool down homes, you have rising power and fuel costs. So heat waves are defined relative to the normal average air temperature at a given location. So a heat wave in August is way hotter than a heat wave in November. So it's just compared to what's normal for the area. A heat wave, several days of higher than normal temperature, that's super vague, but that's as specific as it gets. Here, it's for the rest of our lives. We will always be in this heat wave. It will never end. It started a month ago, and it's never going away. It will never go away. And the high this week is 111, and it's never gonna end, is it? Like, the end is not in sight. I'm sorry. So what are the 5 causes of heat waves? So these deep ridges, clear skies, calm winds, dry ground, and high pressure. So everything that causes sinking air causes these heat waves. Here we go, the big ridge. This is the heat bubble. So ridges are created by a deep layer of warm air, and they're regions of calm and dry weather. And there's a positive feedback. This is the unfortunate thing about the whole event. There's a positive feedback with a deep ridge. So, yeah, so ridge is a region of calm weather, clear skies, calm winds. So, if you have clear skies, you get more sunlight, and you get more solar heating. If you have calm winds, you don't have the temperature advection, so there's warm air that's persisting. You don't have a cold air mass moving into it. It just stays warm. If you have more solar heating, your ground dries out via evaporation, and dry ground heats up faster than wet ground. And then if you have a dry, hot ground, clouds become even more unlikely. So it produces a positive feedback loop that it sustains itself. So if you get a ridge, the ridge just stays there. It gets stuck. So heat waves suck because they just feed on themselves and make things worse just by existing. So surface high pressure centers typically form in the eastern side of the ridge. So the circulation around that surface high can affect warm, moist air into the region experiencing the heat wave. God, I wish that we would get some warm, moist air into this region. I wish we would get some cold, moist air into this region, mostly. I would like to see a storm. Anyway, moisture exacerbates health effects of the heat wave. Oh, that's not good. So, yeah, because people and animals can't cool off as easily because it's harder for their sweat to evaporate. So you sweat because your body wants to cool itself. So remember that evaporation is a cooling process. So you sweat, and then the sweat evaporates off of you, and you cool down. But if there's a lot of moisture in the air, your sweat doesn't want to evaporate. It's already holding as much water as it can. So, it just stays on you, and it is nasty. Your temperature increases significantly. So yeah, a dry heat is much better than a wet heat. Air sinks over a high pressure center, and sinking is drying and warming. So apparent temperature and heat index. I think the heat index formula is hilarious. Like, my professor showed us that formula in class, and I just had to laugh. You can look it up if you're interested. It's really long. Anyway, it doesn't always feel the temperature that it is outside. Apparent temperature apparent temperature means this is what it feels like to humans outside. Like, this is what it feels like outside, like what temperature it feels like. So it takes into account the air temperature, relative humidity, radiant energy, which just means sunlight, and the wind speed. Heat index is the same, but it's assuming some constant radiant energy and wind speed. So heat index is solely a factor of temperature and relative humidity. So does it always assume this? I guess it does. It always assumes that the wind speed is around 5 to 6 miles per hour. The pressure is about 10, 13. And the radiant energy is none, because the person is in the shade. But it can feel a lot hotter than the heat index. If there's no wind, then that water... What wind does is it forces water to evaporate off your skin. So that's why wind feels cool, because it's evaporating liquid off of you. But if there's no wind, it's not going to evaporate the water off of you, so you're just going to be hot. And radiant energy, I think, is kind of self-explanatory. If you're standing directly in the sun, it's going to be hot. Like, it's going to feel hotter. But in this course, we're going to focus on the heat index because it's much easier to calculate, albeit the equation is still hilarious to me because of its length. Higher temps are equivalent to a higher heat index, and a higher relative humidity is also equivalent to a high heat index. So, an excessive heat watch. This is from the National Weather Service, so these are official terms that are given out. They're official watches and warnings. So, an excessive heat watch, here's the definition. An excessive heat watch is issued when there is a potential for the heat index value to reach or exceed 110 degrees east of the Appalachians or 105 degrees west of the Appalachians within the next 24 to 48 hours. So, we're probably under this excessive heat watch for the rest of our lives because it's never gonna stop. It's never gonna stop. I don't think it's ever gonna stop. I've had so much hope that this heat bubble is gonna go away. And it hasn't. And there was one day where it was supposed to rain 2 weeks ago, and it didn't. So I've lost all hope for the future in Norman, and I'm considering leaving. Anyway, an excessive heat warning is issued when the heat index value is expected to reach or exceed 110 degrees east of the Appalachians or 105 degrees west of the Appalachians within the next 12 to 24 hours. So I bet we're under this now, because it's probably going to do that tomorrow. An excessive heat warning may be issued for lower criteria if it's earlier in the season or during a multi-day heat wave. Yeah, so we're probably already under this heat warning, because we've been under this for a long time. A heat advisory is issued when the heat index value is expected to reach 105 to 109 degrees east of the Appalachians or 100 to 104 degrees west of the Appalachians within the next 12 to 24 hours. It can be issued for lower criteria earlier in the season or during a multi-day heat wave. So, the difference between the heat warning and the heat advisory is that the heat warning is hotter than the heat advisory. Why do we issue these? People aren't ready for the heat. Like, they make plans to grill outside and go to Six Flags and stuff, and then it's just not good. nobody should be outside when it's 111 degrees. I will not be going outside. Urban heat island. So during heat waves, the heat is often worse in cities, especially in downtown areas. This is up to 10 degrees Fahrenheit higher, and this phenomena happens especially at night when compared to the countryside. So what happens? More solar radiation is absorbed by dark, man-made materials during the day, so more is released at night. So yeah, you have this absorption of this heat, and it's released at night. And the more, like, roadways are really good at absorbing heat. So if you have a lot of those, more of it's released at night. There's also less evapotranspiration off plants at night, so less evaporative cooling. So evapotranspiration is just evaporation of water within the plants. And evaporation is a cooling process, so you don't get that if you don't have plants, and you don't get that during the nighttime because the sun is not out. The heat from air conditioners and vehicles warms up the area more. Really? I guess. Buildings radiate heat both laterally and upwards, and the lateral radiation retains the heat. Yeah, so like the sides of the building have heat, and they like kind of hold on to the heat until the nighttime. And the winds overall at night are lighter, so you have no advection of cooler countryside air into the city. In the early morning hours, you can get more powerful winds, in my opinion. Especially in the upper levels. But yeah, early on in the evening and stuff, there's lighter winds. Dealing with dangerous heat. Main tip. Stay inside and in air conditioning. Check on the people you know without air conditioning. Find a local cooling shelter if needed. Wear light clothing and limit sun exposure. Stay hydrated and know the symptoms of heat illness. We read those. It doesn't sound fun. Just stay inside. Oh no. Okay, more. This is not a good situation to be in. So heat exhaustion is mild to moderate symptoms of excessive heat exposure. Dizzy, excessive sweating, nausea, cramps, rapid pulse, and the solution is to get into air conditioning or a cool shower, drink water to rehydrate. This happened to me one time when I was in Alabama. That's where my family lived. Now they live in Mississippi, but it was like, I don't know, it was like summer of 2018, and I thought it was like a good idea to go outside and hand wash my vehicle. And like, I went inside and I was so sick after like 20 minutes outside. Yeah, and you just need to drink some water and go inside and stop your activity. A heat stroke is extreme form of this. Headache, confusion, no more sweating, high body temperature and hot skin, nausea, rapid pulse, unconsciousness. You've become a human raisin, and you need to call 911, and also need to cool that person down, and cool them off using cool cloths in a bath. Don't give them anything to drink. Why? I don't know, but Sacramento National Weather Service says not to. If you have heat stroke, just call 911. Let them handle it. They'll give you an IV injection of water and rehydrate you real quick. So, if you're having a heat stroke, dial 911. Okay, that's the end of this PowerPoint. One more. So we just talked about heat waves, and we talked about heat-related illness. I'm going to give both of those a thumbs down. Not a fan. Now we're talking about winter storms, which is the opposite. So we talked about these before. So for the rain, it's it's freezing aloft, but spoiler. Okay, it's freezing aloft, but as you get closer to the surface, this snow melts into rain, and it's above zero at the surface. When you have snow, the entire vertical profile is below zero. For sleet, you have it below zero, and snow forms, you have a little area in the mid-atmosphere where it partially melts, and then it refreezes and before it hits the surface. And then for freezing rain, it falls as snow, it warms up and it becomes rain, and it falls and it hits the surface as super cooled water, and the surface is freezing, so it freezes onto the surface. So, this is an interesting diagram. There's a lot to unpack here. Okay, it all starts as snow. Look at up here. It all starts as snow. And this is kind of like the proportion of warm air, this yellow area. So there's more, the most warm air is in the rain. It falls as snow and then it warms up and it falls as rain. Freezing rain has a little bit more warm air, so it heats up enough to turn into rain. And then it freezes upon impact. So it's like rain all the way down to the surface. For sleet, not very clear, but it's a partial melting. It doesn't become fully melted usually. So if it becomes fully melted and then it refreezes, that's more like grapple. But anyway, it melts and then it refreezes and it forms these like little pellets. Yeah, so sleet is a melting and then refreezing process before it hits the surface. And then snow is just snow all the way down. It's below freezing the whole way. Winter storms commonly occur as a part of extratropical cyclones. Extratropical cyclone is literally another word for mid-latitude wave cyclone. It's what causes the severe weather as well. It's the same exact thing. So an extratropical cyclone is a large swirling storm systems that form along the polar jet, several hundred miles to 1,000 miles across, and it lasts for days to over a week. And this is how we balance the Earth's temperature. So, as the equator warms and the poles cool, extratropical cyclones transfer warm air northward and cold air southward. And they typically occur in late fall to spring when the temperature gradient is the greatest. So yeah, this is your severe weather time. There it is. It's that comma shape. We were talking about this a little bit earlier. That's that cold front right there. And if you are in the right location, this cold front, instead of producing severe weather, is going to put down snow or blizzard-like conditions. Snow, heavy snow, rain, storms. Yeah, so up in this low pressure area, it's colder up here because of simply because of the latitude and the proximity to the cold air mass. Down here in the south, it rarely gets below freezing, so you have rain and storms. And up here in this occlusion area, you have snow, freezing rain, and sleet. Cyclones are the parent storm from which much of the severe weather in the mid-latitudes develops. The extratropical cyclone forms around a surface low. Yeah, so it extends downwards. Like this cold front here extends down, and this is like the tail of the comma, and the warm front extends from the comma head. So, the snow and the winter weather occurs in this region. Sometimes in this region if it's, if you're in the right place. But yeah, typically this is what you look for severe weather, not for winter weather. So, Blizzard, the definition from the American Meteorological Society, a blizzard is a severe weather condition characterized by high winds and reduced visibility. So note, falling snow is not a condition for a blizzard to form. It just says high winds and reduced visibility. So let's look at the National Weather Service specific guidelines for what constitutes a blizzard. So a sustained wind or frequent gusts of 16 meters per second, so that's 30 knots or 35 miles per hour or greater. You need falling and or blowing snow. So you don't need the snow to be falling from the air for the blizzard to form. You could just have it snow on the ground that's blowing. The visibility needs to be reduced to less than 400 meters or 0.25 miles for 3 hours or more. So visibility is a huge part of this. Like in a blizzard, you can't see that far ahead of you. No temperature requirements, just the snow. Okay. Let's talk about the Groundhog's Day blizzard. So this happened between January 31st and February 2nd, 2011. 2011 was hands down the craziest year for weather in my mind. In my mind, I think of 2011 and I immediately think, wow, that year was crazy. So, what happened? Snow and mixed precipitation impacted everywhere from Texas to New England. So, cities that experienced blizzard conditions include El Paso, Texas, Las Cruces, New Mexico, Tulsa, Oklahoma, Oklahoma City, Kansas City, Missouri, St. Louis, Missouri, Springfield, Illinois, Des Moines, Iowa, Milwaukee, is that Wisconsin? Detroit, Michigan, Indianapolis, Indiana, Dayton, Ohio, that's where I was born, Cleveland, Ohio, New York City, and Boston. So that is like a lot of places. The most prolific effects, though, were in Chicago, Illinois. 21.2 inches of snow. That's a lot. Blizzard conditions and winds over 60 miles per hour. This is definitely because of the Great Lakes, which they have a really prominent effect on snowfall. Lakeshore Drive, whatever that is, completely shut down. Do they have anything about the lake effect? I want to talk about the lake effect. Okay, there's nothing about the lake effect, but let me quickly explain it. So what happens in places like Chicago and other areas on the Great Lakes? So you have this air mass that passes over the lakes. And we talked about before how lakes heat up and cool off slower than the area around it. So what happens is during the winter, the lake is warmer than the surrounding air and the surrounding land. So as the storm passes over the Great Lakes, you have extra evaporation and lifting off of this surface. So it really is like, if the atmosphere is like a sponge, it's like soaking up this lake water, this warmer lake water. Then, once the air mass moves off of the Great Lakes back onto this cold surface wrings the air out like a sponge. So it's literally just like sucking this moisture up off the lakes, and then it's wringing it out over the land. So that's why you can get this amount of snow in this area, like Chicago. Here's some pics. I don't know, I lived in Colorado, it looks pretty normal to me, but I guess they're stuck out there, that really sucks. Yeah, I mean, maybe it's not normal, because there's that much snow in that little amount of time, like, that's really bad. How did they get home? I don't know. Here's some sources, if you want to look for yourself. Yeah, that looks cold. I wouldn't want to be there. So let's talk about winter weather products. So there's lots of different types of watches, warnings, and advisories for winter weather. So there's a winter storm watch, a wind chill watch, a blizzard warning, an ice storm warning, winter storm warning, lake effect snow warning, wind chill warning, winter weather advisory, and wind chill advisory. So, like heat advisories, watches, and warnings, they have small details that are not important. They're kind of important if you're issuing them. Um, okay, we'll just talk about the most important points because you're not going to have to issue them, at least not yet. And if when you are issuing them, they'll give you a little guide to do it, and you can also just Google it. But this is for this class. Let's talk about the most important issues in bold, but I'm going to read them all. So, an advisory is issued when a hazardous winter weather event is occurring, so it's happening in the moment. It's imminent, or it has a very high probability of occurrence. So, advisory means, yeah, it's probably going to happen, or it's already happening. Greater than 80% chance, whatever that means. In your mind, if it's greater than 80% chance, then yeah, you can issue one. The percentage chance thing in meteorology is kind of dumb because they act like it's super mathematical, like, oh yes, it is, there is an 80% chance that 100% of this region is going to have this advisory. Like, huh? Like, I don't know, I just wing it and see what feels right, Like, nobody's really calculating any of that kind of crap. Like, you're just putting a number on it. So I think that more likely than not is a better phrase than 80%. But, 80% sounds cool. Like, it sounds like you did something there. So it's fine. So the advisories are issued for less serious conditions that cause a significant inconvenience. Okay, so you get an advisory, like, it's not that bad, I guess, but it's kind of inconvenient. A watch is issued in this 24 to 72 hour forecast time frame when the risk of hazardous weather event has increased. So from 50 to 80% certainty that the warning thresholds will be met. Okay, so a watch is not issued during the event, it's issued before the event, and the further out the event is, like, the less of a chance you're gonna give it. Like, if the event is happening, like, it's happening. Like, that's 100% chance it's gonna happen. But during a watch time, the percentage chance of it happening is a little bit lower. A warning. These products are issued when the hazardous winter weather event is occurring, is imminent, or has a very high probability of occurrence, generally greater than 80%. A warning is used for conditions posing a threat to life or property. Okay, so an advisory, really inconvenient. A warning, you're gonna die or lose your house or something, or it's just not a good event to be happening. So warning is much more serious than an advisory. We'll learn much more about watches or warnings near the end of the course. I'm sure we will. Okay, here's winter weather product. Yeah, so go to weather.gov/Norman. This weather.gov website, this is just like, I don't know, it's a godsend. The weather.gov website can give you a lot of information. Weather.gov/Norman, even better. It gives you all sorts of things. We're the best meteorologists in the country coming up with forecasts for you, so you don't have to. Until you work there, or, whatever. But for right now, it's a great tool. So for this, we have a winter storm watch out here. So the storm hasn't moved through yet to this area. It's gonna happen, though, within the next day or so. Winter weather advisory. So in these areas where it's purple here, winter weather is happening or is close to happening. It's most likely going to happen. Really good chance. But it's just going to be inconvenient. This winter storm warning, this area, it's dangerous. Like, pipes can burst. The temperatures can get so cold that you will get frostbite. Like, it's not safe to be outside at all. And I was here for this day. No, I was not. Never mind. I didn't live here at this point. So who knows what happened. But, we get a lot of ice storms here, and that stuff's crazy. So wind chill. It's kind of like the heat index, but it's for cold temperatures. So it's kind of like the feels like temperature based on the actual temperature and the wind speed. So if you have faster winds, your wind chill is going to go up because it's going to evaporate that water off your body and just like sap the heat out of you. So here's a chart, the wind chill chart. So as you can see, at 5 miles per hour, the frostbite warnings, like, it takes a lot longer to get frostbite than it does if the wind is at 60 miles per hour. Like, the wind chill is much higher for 60 miles per hour. So, like, for instance, let's say the temperature outside is 0 degrees and there's no wind. So it's 0 degrees. At 5 miles per hour, suddenly it feels like it's negative 11 outside. At 60 miles per hour, it feels like it's negative 33. So wind is a very significant factor in wind chill. Frostbite sucks. A freezing of your skin and your body tissue just beneath it, so it affects places where blood circulation may be limited first, so like your toes, your fingers, your nose, and your ears. Cover it up, wear gloves, wear thick socks, wear boots, wear a scarf. All good things to prevent frostbite, but mostly stay inside. And first sign is redness of pain on the area of your skin, white or grayish yellow area of skin that feels unusually firm or waxy, and numbness. I used to live in Colorado, and I would just go outside, and I'm pretty sure that I have almost gotten frostbite. Like, I've felt all these sensations, and when you go back in and you, like, put your hands in warm water, it literally feels like your hands are burning. Like, I don't know. Hypothermia, dangerous low body temperature that is the most common winter weather killer. You don't want it. It can happen in temperatures as high as 50 degrees. That really sucks. A huge contributor is wet clothes. Yeah, so your clothes can, like, freeze onto your body. I think they can freeze onto your body, but I think what's more important is that if you have wind, it's going to evaporate that water off of you, and it's going to cool you off significantly. Symptoms include shivering, exhaustion, confusion, memory loss, slurred speech, and if you're a baby, bright red cold skin and low energy. And this is what happened to Leonardo DiCaprio in the Titanic. He had wet clothes, and it was really cold outside, and we all know what happened. So, yeah, here's whoa, a person's temperature is below 95 degrees, get medical attention immediately. So this is what we already talked about. It's just a big infographic. She does not look happy to be out there. So, here's how to prevent it according to the National Weather Service. Stay dry, so wet clothing results in much faster heat loss from your body. So wear waterproof and insulated boots. Stay covered. Wear mittens or gloves. Wear a hat. At least half of your body heat is lost if your head is not covered. Dress layered, so trapped air between loose-fitting clothing helps to insulate. Yeah, so wear a bunch of layers. Stay informed. Have a portable NOAA weather radio nearby to keep you up to date with the latest forecasts and warnings. I usually just use my phone. Use wind chill temperatures to guide you to dressing properly from the outdoors. On very cold days, minimize your exposure to the outdoors if possible. And if you have frostbite, hold the frostbitten area closely against warm skin to return blood flow and warmth to the affected area. And if you or someone around you has hypothermia, get immediate medical help, and the victim should be warmed slowly with warm liquids along with dry clothing and blankets. Alright, that's it for today. So, very unfortunate scenarios we talked about. I hope none of you are ever in that scenario, but it's good knowledge to have, and especially if you're going to be warning the public about these things. So, email me if you have any questions, and have a great Tuesday.